Yeah, hey. How many of you were here for the last two sessions? So are you tired about hearing Gradle? If yes, I'm sorry, it's going to be about Gradle again. So as developers, we're often waiting on things, and quite often we're waiting on Gradle, and don't trust Randall, the webcomics author, waiting usually isn't that fun. Even if you have swords, you're going to get tired of sword fighting. So let's see if we can make Gradle a bit faster, so we have to wait less. First off, two really important concepts before we go deep into Gradle. Your mileage may vary. I did a bunch of measurements. I did them on my laptop on a few example projects. It might not have the same effect on your projects or on your laptops, depending on your configuration, the state of the stars, whatever. So you should always measure yourself first. Measure where your bottlenecks are, and also measure, like, if you apply a trick to get your Gradle faster, measure before and measure after, so you know what actual effect it had. Because it might even have like detrimental effects. So Gradle, if you were here before, you've already heard this. Gradle has three build lifecycle phases. It has the initialization phase, the configuration phase, and the execution phase. And the initialization phase just picks the projects, what to build. The configuration phase, it will evaluate your build Gradle scripts, configure all the plugins, apply all your plugins basically, and also run all of these after evaluate blocks to get the task graph. And the execution phase will actually execute whatever tasks Gradle wants to run. So I like to categorize them in two. The execution part, that's the useful stuff. That's what actually builds your APK. And the initialization and configuration time, that's sort of the useless stuff. That's like the Gradle overhead. I don't really care about that part, but that's the tax I'm always paying whenever I run Gradle. So first off, let's look at the initialization and the configuration parts. And yeah, as I said before, this is the overhead. Whenever you do anything with Gradle, you will run these two parts always. So if you do like a sync in Android Studio, you will hit it. If you run lint, or if you run like unit tests, which might take just a few seconds, you will still pay the tax for this overhead. So let's see what we can do about this. And first off, let's measure, and to measure something, we need a test subject. So I picked the Google I/O app. It has 28 libraries, 50K method references, so it's not multi-text yet, but it's almost there, and it's open source, so you can try it out yourself as well, if you want to. And to measure it, I use this really, really cool Gradle flag called the dry run, and it does what it says on the tin. It basically evaluates your project fully, it configures it, but it won't run any tasks. So if I just look at the build time with the dry run, it won't run any tasks. They all say skipped here, but it will do the configuration. So the time here, that's the overhead. Every time I run Gradle on this project, I pay 4.3 seconds of overhead just for the configuration, right? And another really, really cool flag is the profile flag. This one will dump an HTML file containing your Gradle profile into your build folder. So you can open it and inspect what exactly is taking the time here. And if you notice, I still ran this with dry run, so let's take a look. Oh. I hope it's still readable. A bit smaller, yes. So this was dry run. As you can see, all of the tasks were skipped. Just a few milliseconds spent on each of them, or maybe even 0. So let's look at the configuration times instead. Okay, and here I get a per project breakdown in this application of the configuration time spent. And as you can see, the I/O app, it actually comes with two components. The Android, that's the application itself that builds the APK, and the server, and that's the backend component. And if I'm just building an APK, I don't really care about configuring the backend component, right? I just want to get my APK. I don't want to spend any time on the server. Yet here, we spent almost a second just configuring the server. So there's a neat little option for that in Gradle. If you pass configure on demand, then Gradle will figure out that it will only configure the projects that you do want to build. So if I want to make an APK using Android Assemble Debug, then passing configure on demand, which doesn't fit on the slide here, will make it slightly faster. We get this 700 milliseconds back because we don't have to configure the server project, right? So that's already one takeaway. If you have a project that has either multiple applications or like an application and the backend component, and you don't need to build them all at the same time always, then just add the configure on demand. And you can enable this globally through a magic file in your user home directory. And it's all documented in the Gradle user guide, by the way. It's really, really comprehensive in that regard. And also, there is an option in Android Studio in Preferences, Build Execution Deployment, and Compiler. There's a small little check mark saying Use in Process Build. And right now, okay, we went from 4.3 seconds to 3.6, and that's a 17% win. It's already awesome, but let's see if we can push it any further. So this is probably really well known, but it's really, really, the impact is so huge that I must go over this again. So Gradle has this cool little feature called the daemon mode. And what this will do, it will keep an instance of Gradle actually running in the background after your build finishes. So if the next time you kick off a build, it will actually reuse that JVM and that Gradle instance, and it will try to cache as much as possible about your build. For instance, the plugins and all of that stuff. So just using the daemon will have a huge effect on your build times. So we went from 3.6 to 1.7 here. And just as before, there is a magic flag in the same file as the previous one where you can enable this globally. And recent Gradle versions, actually, I think they've started to nag you about this as well. They're telling you, like, this build could be faster, just use the daemon, please. And in Android Studio, there isn't a specific daemon option, but there is a flag called Use in Process Build. And it's on the same screen, Preferences, Build Execution Deployment, Compiler. So make sure that that one is set. It was actually enabled by default in 1.3, I guess, where it was hidden, and then they added it back in 1.4, where you can select or deselect it. Cool. So now we're down from 4.3 seconds to 1.7 seconds, and that's a 60% win already. Let's see if we can do any more. Yeah. So Gradle apparently has gotten faster with each subsequent release. So the project by default used Gradle 2.2.1, which is quite old now, and I tried it out with the latest Gradle 2.8, and this is already with the daemon and all of the other options enabled. And now it went from 1.5 to 0.9. And the real gain here is starting from Gradle 2.4, I think they started caching the build.gradle compilation units as well. So if you're not making any changes to your build.gradle files, using a newer version of Gradle will give you faster builds. So please update your Gradle. And this one is not a global setting anymore. So this is configured per project. In every Gradle project, there will be this Gradle wrapper properties file under Gradle/wrapper. And that one will define a distribution URL property where you can also define the Gradle version that you're using. So if you generated your project a while ago, like with Android 1.0 or even one of the pre-release beta versions, you probably might have a really old version of Gradle in here. So it's worth to check this out and just update it every once in a while, just to make sure you're always running on the latest and the greatest. And so far, now we went from 4.3 seconds to 0.9 seconds for the configuration overhead. And that's 5x faster. If I run lint, or if, say, my unit tests run just for a second, I don't have to wait for 6 seconds now, I have to wait for 2, and that's a huge thing. Or syncing after adding a new library, or any of those things. Let's take a look. I think we could probably squeeze a bit more out of this, but I sort of ran out of ideas, but I'm gonna also show some common pitfalls that will take this pretty fast time back up to multiple seconds. One of them is using an old version of Java. So on Java 1.6, they don't, if we want to get technical, they don't have the invoke dynamic instruction yet. And Groovy is a dynamic language, so it can really benefit from that. And Groovy is used to run your Gradle scripts, right? So just using an up-to-date version of Java will also speed up your build. On the command line, you can do this by just specifying the Java_home environment variable, And in Studio, if you go into File, Project Structure, SDKs, there will be a setting called JDK Location. And you can just specify which JDK to use there. So check out that you're using actually 1.8. I'm just installing it and having, like, say, 1.6 installed at the same time. You still might be using the old 1.6 version, not the newer 1.8 one. Cool. Also, another thing is Gradle does a lot of I/O. So in this example, I built an APK, and then I built it again, so everything should be up to date. It shouldn't build anything, right? But at the same time, I captured all of the syscalls, specifically OpenStat and FStat, and just counted them. So doing a fully up-to-date build, in this case, did like 35K syscalls just for I/O. So Gradle does a lot and a lot of I/O. So if you have the money, and you're still on a spinning disk like an old HDD or something, just buy an SSD. It will speed up your builds a lot. Also, if you're like on a fully encrypted drive and it's not really a requirement from your employer or you're working on an open source project, measure what the overhead of your encryption system is. It can also affect your build times negatively. And of course, don't do any really weird stuff like putting your project or the SDK or the JDK on a shared network drive, because that will totally obliterate your performance. I've seen this once, wasn't nice. And also, if you try to make your Gradle build a bit more convenient, you might find these different snippets on Stack Overflow to automate some parts of your build configuration. For instance, what this does here, it will take the current branch, and it will count the number of commits on it, and then use that for the version code. And that's a really neat little trick, right? So I will get like an atomically increasing version code. So every time I make a new commit, my version code in the manifest will be higher by 1, and it can never decrease unless I start deleting commits or something. So it's really cool, but at the same time, you always have to consider, okay, what's the overhead of this? So I took a pretty large repository, the Gradle repository itself, that has 23,000 commits, and in this case, we're spending half a second on just counting those. So if you add anything like this, be mindful of what it's actually doing to your build performance. So in this case, I'm just adding half a second of computation every time I run a Gradle build. So what you might want to do instead is just check if you're in a CI build. I'm developing locally. I don't really care what my version code is, and then I'm just going to use a hard-coded one, which takes, of course, 0 seconds to compute. And on the CI build, where I do care about the version codes, because those updates I'm probably going to publish to Google Play, there we can actually run a bit more expensive computation, because we don't really care about half a second on the CI side. But locally I might care. And also, another really common pitfall is having dynamic dependencies. So these are really useful, right? I'm depending on JSON. I'm just putting 2 point plus there, and what it means is Gradle will keep checking from time to time if there is a new version of JSON available, and then update it. So I will be on the latest version of JSON, but at the same time, it comes with a cost, right? As I said before, it has to check it from time to time. So say I do a build on the morning of October 27th. All is really nice, 700 millis, it's pretty quick. I take a time machine and I travel to October 28th. And now suddenly my 0.7 second build is down to 1.8 just because of this one dependency. And Gradle needs to check, go out into the internet, check Maven Central or JCenter or whatever you have configured, do a head request and see, okay, do I have a new version of JSON available or not? And this will take time. And if you have more dependencies, it will of course do more requests. And if you have more repositories, then it will hit all of those as well until it finds one. So one workaround for this would be to add the offline flag. And now this tells Gradle that don't ever do any network requests, if at all possible. Just use whatever is cached there and use that, right? But an even better solution would be just to fix the version. Because in that case, the first time you build, Gradle will check, okay, do I have 2.3 cached locally? If yes, it's going to use that directly. And if it doesn't have that one, then it will hit the network to download the dependency. So it will win, especially like if you start working on a Monday morning, then I can almost guarantee you, unless you work the whole weekend, that Gradle is gonna do this for all of your dependencies. So just use fixed versions, and the nice side effect is that you also get fully reproducible builds. So a build that you built like from some commit 1 month ago will be the same as the build you're building right now, because it's using those fixed versions. So it helps with debugging as well. And another thing is I measured manually the time Gradle takes and the time Gradle reports. And there's, if you see, there's like 450 millisecond difference here, and I think that's the JVM boot up itself. So Gradle added this cool mode called the continuous mode, where it will run within the same JVM and keep running until you tell it to exit, basically. And it will start a new build every time any of the input files change. So this is really cool if you have fast-running unit tests and you want to run them as you're developing just to see if you're breaking any tests or not. So you could have this running on your second monitor, write code, and just glance at the second monitor every now and then to see if the tests are passing. And the nice thing about this is the least performant part of Gradle, which is like typing in /Gradle W Android test debug unit test, takes way longer than the 700 or 800 millis here. So we're eliminating that human part of the equation as well. So continuous builds are cool. Try them out if they fit your workflow or not. Just to quickly reiterate the main things I want you to take away from here about the configuration phase. If you have multi-project builds, especially they build multiple apps within one project, try out configuration on demand. Definitely enable the Gradle Daemon and the in-process build option in Android Studio. The newer versions of Gradle are faster. Turns out that the newer versions of the JVM are also faster. Avoid doing expensive things during the configuration phase, like the Git example, but you might also like read a file or make an HTTP request or do any expensive I/O right there in the Gradle script. Try not to do that. And don't use dynamic dependencies. Cool, all of this is really cool, but my 50-second build or 15-second build is still slow. So the configuration time, I mean, it was 4 seconds, but every time I build an APK, it takes way longer than that, right? Let's see if we can do anything about that as well. So before that, this has been touched briefly in the previous 2 sessions as well. Gradle has a concept called a task graph. And to demonstrate the concept, I'm actually going to use the plain old Android Gradle build, or sorry, plain old Java build, not an Android build, because it's a lot simpler. So in a Java project, if I run /Gradle W jar, I tell Gradle to build a jar for me out of this project. In the configuration phase, it will configure the jar task in a way that it depends on the classes task, and the classes task in turn has been configured in a way that it depends on compile Java and it depends on process resources. So this is a really, really simple task graph. And what happens, and this is the input to the execution phase, right? So Gradle knows that to build jar, I need to build classes, and to build classes, I need to build compile Java and process resources. So just to walk through of that process, I asked Gradle to build a jar. It will start here. It will check, okay, I need to run this task. Have all of my dependencies been met? Nope, I haven't built classes yet. And the same thing for classes. Are all of my dependencies met? Nope. So let's try to build compile Java. Are all of my dependencies met? Yep, because we don't have any. And so Gradle can go and just call compile Java and run that task. And this one will take the .java source code or Java source code you have and turn it into Java bytecode, the .class files. And now it won't still be able to build classes, right? Because it also needs the resources. So same thing happens here. Can I build process resources? It doesn't have any dependencies. Yep, we can. It will collect the resources, and now the classes task can collect both of them and put them in one folder. And that one is fed into the jar, which just zips it up and emits the jar somewhere. So why this is important is Gradle reuses the outputs of the tasks. So if inputs haven't changed to any given task, then the outputs can reused as well, can be reused, right? So in this project, for instance, say I change a resource and I run the same task again, then only the process resources, only this task and also the jar, only the 3 out of 4 will be executed again, but compile Java won't, right? So if you want to minimize your build execution, you have to be mindful of what am I changing and what am I changing and which outputs and inputs to tasks are changing. So to demonstrate this in an Android project, I wrote this neat little Gradle plugin that actually emits the full task graph of an Android project, and it got a bit out of hand. It's not even supposed to be readable. So I simplified it a bit. And this is a really huge simplification. There is no AIDL here, there is no render script, no NDK. It's, say, a really simple Android app with just some Java code and some resources. So the main parts of an Android build is the package, and that's the one that signs and builds the APK. There's process resources that takes your layouts, your strings, also the manifest, and turns them into a binary representation that's actually needed on the device. So there's no plain XML anymore on the device. So that's what process resources does. And at the same time, package also depends on the Dex task. And the Dex task takes the Java bytecode emitted by the Oracle Java compiler and converts it into Dalvik bytecode that's being used on the devices, right? And the Dex task, as I said before, depends on compile Java. And the funny thing here is compile Java in turn depends on process resources because resources need to have these generated IDs, right? So if, say, I add a new resource, then both Java and also the res AP file that's been used by the package, both of them will be changed. So in some cases, you can see like there are 2 paths in a build here, right? There's the resources path, and at the same time, there is the Java change path. And we'll get to why that's important in a moment. So to measure these paths, the easiest way is just to add a new resource, because then we will basically run a full build. We will need to process the resources, and since we're adding a new resource, it will also touch the r.java file and add an integer ID for our newly added resource. In this case, I'm just adding a new string and then profiling the build. And it takes 7.6 seconds on my machine. I can show this, but I'm not sure if it's going to be any readable. The important part about the profile report is it will actually order things by the time they've taken. So if you look at task execution, you just usually need to look at the first 4 or 5 or so. I'll go back because I probably have the times in a more readable way. Yep. So for this Google I/O application, the package took 1.3 seconds. And that's something we have to pay always because we have to build a new APK, right? Whatever I change, if I change Java code or if I change resources or even if I change native code or whatever, then we still have to make a new APK because otherwise, if I don't have any changes, then why would I even want to build it? So that's the cost I will always pay, the 1.3 seconds. If I only change resources, then there are 2 important tasks that kick in. The merge resources that takes the resources from all of your libraries, from all of your build types, all of your product flavors, merges them together into one giant res folder. And then the other task, which is process resources, there's a tool in the Android SDK called apt that takes care of this. It will take this giant res folder and then just compile it into this binary format that's needed for the APK. And these both together take roughly 1 second. Java is a Java change is a bit costlier. So there are 2 really important parts here. One of them is the Java compile or Java C. That takes a second on its own. So that's just to compile your Java source code into class files. And the really costly part of any Android build is the Dex step. And that's converting the Java bytecode into the Dalvik bytecode. And this is like half of the build here, right? So if you ever do something like this, this snippet here will add a new field in build.config.java called build date, and it will contain the string representation of the current timestamp. You could find snippets like this on Stack Overflow as well. So as I said before, always be mindful and try to understand how it could affect your build. So in this case, every time I build something, the build config.java will change, right? So even if I change a resource that could I could spend this 1 second plus the 1.3 second for the package, I will also pay the Java C and the text cost, even though I didn't change anything. So really try not to have like automatically generated changing values in your Java files, if at all possible. So what we could do, we could turn it into a resource value instead. Because now we're just paying the 1 second cost and all is good, right? Well, it's still a bit bad, because if I do make Java changes and I don't make any resource changes, now I'm suddenly paying this 1 second extra just because I have a changing resource value. So it's not as bad as it was before, but it's still one second that is pretty much useless for me. I mean, I'm a developer, I just built this. I don't really need to know when it was built. So what you could do here is, just for the debug build type, you could put whatever like fixed hard-coded value in there. Because yeah, I don't really care. And for the release versions where I might use this value, say for crash reporting or something else, it might actually be useful there. So try to optimize for the debug use case, which is what you're running locally, and the release use case, you might build them locally from every now and then, but usually you're running them on the CI server instead, where a second does not cost as much. Yeah. So the Dexer. The Dexing was like half of this build, right? So let's try to understand what the Dexer does. There are two tasks in a normal Android build called the Predex task. And this one takes all of your library dependencies, and it will text them and then cache them in these .jar files. So what this means is, if I run a build once, then I go and make some changes, and I run the build again, then all of these libraries don't need to be dexed again, right? Because we've already dexed them. And the actual dex task itself will just dex your application code, but it won't dex the library code. We've already done that. It just needs to merge them together. So there's like an extra merge step there, where it takes your application dex, all of the library dexes, and then merges them together into this one huge text file. And where I'm going with this, here's an illustration of the same thing. Dex depends on predex, Java compile. It consumes the class files from Java compile. It consumes the .dex files from the predex. And the funny thing here is, starting with Lollipop, or API level 21, Google added native multi-dex support into Android. So if I create a new product flavor just for development, I call it dev. I enable multi-dex on it, and I also say that this will be minSdk version 21, so it's targeting Lollipop or higher. Then now suddenly this merge step is useless, right? Because what you could do, you could just take the application dex, take all of the library dexes, and then just put them all together into the APK without merging them. Because it works on Lollipop. So let's just try that out, and this immediately takes 2 seconds out of those 6.6 seconds. There is one caveat here. When I was preparing these slides, the latest build tools version was 23.0.1. In 23.0.2, they optimized exactly this part. So I'm not sure how big the effect is at this point anymore. But I will definitely update the slides before I publish them. So maybe this trick is not as cool anymore and won't give you as many gains. You might get them for free. But if you do need to multi-dex, if your application actually has hit the 65K method limit, then you definitely need this trick. The thing here is, for assemble prod debug, minSdk 15 and multi-dex enabled true, the build times are absolutely horrible. And what happens here is, to multi-dex properly on lower API versions, you need to have the multi-dex support library, right? And what that does is it will add these additional dex files into the class loader at runtime. But to do that, it needs to ensure that all of your components in the manifest are in the original main dex file. And some of these components can actually come from libraries. Like if you're using whatever library, like some tracking library that comes with an Android service, then that component goes into the manifest, and it also needs to be in the main Dex file. So the effect of that is you totally lose the predexing part. If you have multidex enabled and you have a lower SDK than 21, then every time you make a build, it will dex everything, all of the libraries, all of your application code every single time. So that's really costly. So if you do have multidex, definitely create the new product flavor with minSdk 21. There's a 5x difference here. And let's talk about really large projects. How many of you have like a multi-minute build? Oh, wow. So I used to have access to some of these, but I don't really have access to any large projects anymore. And Iosched was pretty quick. It was 4 seconds, so it didn't cut it anymore. So I created an artificial Android large project. It has 45 libraries, like all of the daggers and retrofits and whatever is popular at this point. The source contains 3 separate copies of Guava in different packages. And when I just build it, it produces 3 Dex files and 150K method references. So it's way past the multidex barrier. And if I do a one-line Java change here, it takes 50 seconds, not 5. I wish it was 5. So immediately, first thing, because it's multidex, right? Let's just bump the minSdk to 21. And this brings it down from 50 to 18 or 19-ish. And that's a lot better, but it's still a pretty sizable amount just for waiting. So, I'm not going to show the profile. Maybe I don't even have it. So for this 19-ish seconds, I spend 8 seconds on dexing. This is already with predexing applied, so it's just one of those Guavas, or like all of those Guavas getting compiled, but not the libraries. I spent 7 seconds on Java-C, which is pretty bad, and I spent 3 seconds on package. And I can't really do anything with the package, but I might be able to do something with the Dex and the Java-C parts. So one way to break this down a bit is to utilize predexing, because it worked really well for libraries, right? If I take 2 of those Guavas, I put them in a separate library projects, and I consume those as dependencies from my app code, then those Guavas will actually get predexed. And it's, for me, it was really easy to do because I just moved some folders. If you have an actual large Android project, it's probably pretty hard to achieve that level of decoupling. But if you have a project of that size, I would argue that you probably should do it anyway, just for your own sanity's sake. So now when I make a single line Java change, we're down from 19 to 9 seconds. And both the Dex times and the Java-C times, they have like decreased considerably. Because now we're just only dexing one of these Guavas, we're predexing 2 of these Guavas and reusing that output. And we're also just running Java compile on a much smaller source set. So you could say, okay, but what if I need to make a change that affects all of my code base at the same time? Like I have a core library that's being used everywhere, and I want to make a change in there. So I did a really quick test with this. I added empty classes to both Guava 1 and Guava 2, and I run app assemble debug again. And for my surprise, it was actually still faster than the 19 seconds. It was 16 point something. And it took a moment to actually realize what's going on here. It's just a side note or an anecdote, I guess. So Java-C runs in both Guava 1 and Guava 2, because we added new classes there. And Java-C will also run in app. Even though we didn't change the source code, we did change the dependencies. So every time you change the dependencies, Java-C will run just to see that your project even builds. Like, you can change a method signature, and then it needs to run it again to know that it's actually linkable. And Predex runs again as well, because both of these jar files have changed. But the main Dex in app is actually up to date, because the app classes themselves haven't changed. Java-C did run, but the outputs all have the same hashes, and then Dex figures out, okay, I have the same inputs, I can reuse my outputs again. So it's a really good example of how understanding the inputs and outputs can make some substantial differences in your builds. But we can actually go a bit further with the same example. So Gradle has a parallel flag, and it's also present in Android Studio in build execution deployment. And you could think that this actually enables task level parallelism, but it doesn't. It's just project level. So If you have like an app module or an app project and it depends on multiple library projects right there in the same source tree, and those two are decoupled from each other, then it can actually start compiling both of these at the same time. So in my case, it's a perfect example where I have two exactly the same size libraries, so I get the most win here. But it will parallelize your build to an extent, to some degree at least. A few seconds in this case. And the documentation clearly states that it requires decoupled projects, and decoupled projects are not that well defined. But as far as I could understand, if from one project you actually take the project object of another project and you start messing around with the object values in there or the configuration in there, then you probably won't have decoupled projects. So you should only depend on artifacts produced by those sub-projects, not mess around directly. And there is also incremental Java compilation since Gradle 2.1. It comes with a warning that it's still incubating, but it's there. So in this case, if I add this option to both Guava 1 and Guava 2, I win like an additional 3 seconds because it doesn't need to compile the full source tree. It can only figure out, okay, just these few files changed. I can now just run javac on those files and get the outputs. But it comes with a really huge caveat. It only works for Java projects. It doesn't work on Android projects. So if you have your laptop right now, I would love if you just went to b.android.com/82411. I don't have any Wi-Fi, I would do it myself. And there is a small little star that's not filled in the top left corner. If you click on it, then you will start that issue and it will raise the visibility to the Android tools team that they should fix this. I'd be really happy if they did. Yeah, and this is pretty tolerable, right? We went from 50 to 11 seconds. There will be the install time on top, but it's basically getting there. And the future looks a lot better compared to what we have right now. So the Gradle experimental plugin, it's out already. You can try it out if you want to. It should help with configuration time somewhat, especially if you have like really large project structures. Say you have 50 or 100 sub-projects in one huge Gradle build, then the experimental plugin should help there. But it's still, as the name says, it's still experimental. And the new Jack and Jill toolchain promises an incremental path from Java to Dex. So in that case, if that ever happens, it might work right now. I haven't tried it in a few months. So in that case, you can just change a Java file and then rely on the Jack and Jill toolchain to update just that part of the Dex, basically. Really, really experimental. I haven't really tried this out, but I'm hoping. And also, there are alternative build systems. You might have heard of Buck, but it also has two brethren called Bazel and Pants. They're all based around the same ideas. They have really lightweight sort of like modules or mini projects that are really quick to configure. They have a much higher degree of parallelism than Gradle does, and the builds are really, really fast. Like a clean build of Iosched, I think, took less than 15 seconds with Buck on my machine. But at the same time, the ID and both community support might not be there yet. You might not really find any answers to your problems. You might need to go on IRC and talk to the developers directly, because they're still like fringe build systems, right? Everybody's using Gradle, or maybe aren't. And they also require rather a substantial restructuring of your project. But if you're really hurting, then it might be worth to look into that. And there's also JRebel for Android. It's the product I'm working on in ZeroTurnaround. We enhance your Gradle build in a way that we still rely on the Gradle build process for resource processing and javac, but we make the Dex package and install steps full incremental. And on top of that, the changes are applied into the already running VM on the device, so you don't need to start your app from scratch. If you want to check it out, it's bit.ly/JRA-Droidcon-Gradle. Give it a go or come ask me about this. And that concludes my talk. The slides will be up on SpeakerDeck. They are not there yet. Once I figure out how to get them there, They will be there, and I will definitely tweet out when that happens. Cool, thanks. I think we have some time for questions.
Yes, exactly. Well, 5 minutes questions, if you have.
Everybody is tired about Gradle.
No question?
Oh, there is one.
Can you hear me?
Yep.
Okay, so I didn't understand the part where you create like imaginary big project where you included 3 guava jars, and you said that there was a difference if you included them like separate projects against including them. I didn't understand what were the differences, but the Predex was had more effect when you included them as separate projects. So could you explain that?
Yeah, I probably wasn't as clear as I should have been on that. I actually included them as source. So I took the source of Guava and I put it in app source main Java so that Java C runs every time. And then when I extracted them into libraries, I just added them, like 2 of them out of 3 as source files in those. So I was just trying to emulate like having a really large project with a ton of .java files, basically. Yeah.
Hi. You present in build times about seconds, but our build times are about minutes. And, we wondered if it's possible to remap build on another very powerful machine. Or is there any clues to do this, or is it impossible for now?
It's definitely possible, but not really easy to do with Gradle right now. So for instance, if we go back to the alternative systems, I think Puck has it built in. So they, like the task outputs or the build rule outputs in Puck's case, they can actually be cached in a network server somewhere. So if a developer next to you has built this code already, then it can reuse the outputs. And I think Gradle, I've seen hints of it coming at some point, maybe Gradle 3.0. But I'm not sure. But it's not about like having a separate faster build machine. It's more about just reusing the outputs. But it has the same effect. So let's hope.
Okay, no more questions. Thank you very much.
Cool.